Hi and hello everyone, this is Ravindra Babu. Welcome back to my channel Silver 90s Bionit. Today in this part of videos of molecular basis of inheritance, we are going to prove that code is a triplet and code is continuous at a genetic basis through frame shifter mutations. Actually, I wanted to complete this concept in the last video, but the discussion of mutations only took a long time, so that I could not explain it. The frame shift mutations, whichever we discussed in the last video, mutations are actually based to understand this concept of genetic proof for code as a triplet and code is continuous. I have provided the link of this mutations video in the description. If you want to watch it, you can go through that link provided in the description. Before we go into this, here a small request from my side. Kindly watch all my videos made on this molecular basis of inheritance for better understanding of the concept, and one more request is please like and share the videos and subscribe my channel. Let's begin our today's topic, that is the genetic proof for the code as a triplet and code is a continuous. This frame shift mutations provides a genetic proof for the code is a triplet and code is continuous. Let us understand this by taking a statement of some words having 3 letters each, like that of the triplet codons on the mRNA molecule. So this is the statement: Ram has red cap. Consider these words of 3 letters as a triplet codons on the mRNA molecule. First, let us prove this by taking the insertional frame shifter mutations. In the insertional frame shifter mutations, in the first case, a nucleotide B gets inserted before the nucleotide R of this statement Ram has red cap. Due to insertion of a nucleotide at this point, here you can find a shift in reading frame of the triplet codons of this statement as Ram has BRE. Here BRE would form a triplet, and this D with the CA forms a triplet, and P with the other 2 nucleotides would form another triplet. What happened here? A shift in reading frame from the point of insertion of a nucleotide, which means the insertion of a single nucleotide resulted in shift in reading frame from the point of insertion. If we come to the second case of insertional frame shift mutations, where the insertion of 2 nucleotides occurs at this point, nothing but before that nucleotide R. Due to insertion of the 2 nucleotides at a time, here there is a shift in reading frame in this statement as Ram has BIR EDC AP. Here BIR forms a triplet codon, EDC would form a triplet codon, AP with another nucleotide would form another triplet codon. What happened here also? A shift in reading frame from the point of insertion of 2 nucleotides. The conclusion is even the insertion of 2 nucleotides also resulted in shift in reading frame from the point of insertion. But in the third case, where we inserted the 3 nucleotides at this point, what are the 3 nucleotides? B, I, G. If were inserted before the R, a new triplet codon would form BIG, like this, which does not result into any shift in reading frame. The 4 triplets Ram has red cap remained as such original, but you can find the additional triplet codon at the point of insertion of 3 nucleotides. The conclusion is insertion of 3 nucleotides does not result in shift in reading frame, which means no shift in reading frame of the statement. In the first 2 cases, where the insertion of 1 nucleotide and insertion of 2 nucleotides resulted in shift in reading frame from the point of insertion. But in the third case, where the insertion of 3 nucleotides does not result in shift in reading frame from the point of insertion, which concludes that the code is a triplet and code is continuous. If the code is not continuous, there could be no shift in reading frame in the first 2 cases. and the reading frame could be RAM has RED CAP, red cap. In the second case also, the reading frame could be RAM has RED CAP. Well, if the code is not continuous, but here the code is continuous, hence the shift in reading frame like BREDCAP, BIREDCAP. We can also prove this code is a triplet and code is continuous through deletional frame shifter mutations also. Let us move on to that. So this is the statement ROM has a red cap. If it undergoes a deletional frame shift mutations, in the first case the deletion of one nucleotide R at this point resulted into shift in reading frame as ROM has EDCAP. ED with the C form a triplet codon and AP with another nucleotide forms another triplet codon, which means the deletion of one nucleotide resulted in shift in reading frame. In the second case, the deletion of the two nucleotides R and E from this reading frame. Here in this case also we can find a shift in reading frame as ROM has DCAP, as R and E gets deleted here, D with the CA forms a triplet codon, P with another adjacent nucleotides would form another triplet codon. Here also there is a shift in reading frame, means the deletion of two nucleotides also resulted in shift in reading frame. But in the third case of deletional frame shift mutations, the deletion of three nucleotides at a time RED does not result in shift in reading frame. The reading frame remained with three triplets. As such, it just lost one triplet at the point of deletion red, which means the deletion of three nucleotides does not result into shift in reading frame. No shift in reading frame. This deletional frame shift mutations also concludes that the code is a triplet and code is continuous. If the code is not triplets, they could not find a shift in reading frame in the first two cases. If the code is not continuous, they could not find a shift in reading frame in the first two cases of this deletional frame shift mutations and insertional frame shifter mutations. This is all for today's video. In the next video, I will come up with a new concept of central dogma of molecular biology, that is the third event of central dogma of molecular biology, translation. Thanks for watching. Like and share the videos and subscribe the channel. Vidyaya Amrutam Ashnute.